Lesson 3, SCADE One. Here you can see the new SCADE One IDE. The IDE has 4 main parts: the Workspace, the Model Explorer, the Job Explorer, and the Job Graph. In the Workspace you can organize your projects and your libraries. You can define the dependencies of your projects. In our case, you see that the A-star project is using the field project, which is the Rapid Prototyper project. The Model Explorer is the area where you will find all your project elements arranged in a tree view. You will have modules, operators, constants, types, and so on. In the Job Explorer and in the Job Graph, you will find all your tasks or actions or jobs that you want to perform on your project, which are code generation, debugging, report generation, just to name a few. Main data and OpenSet. Before we can start implementing the logic, we first need to think about how we shall store the information that is needed in the algorithm. On the one hand, we need to store the cost values and the traveled path. On the other side, we need to find a static method to implement the two sets, open and closed. The closed set is easy. That is basically just a boolean flag for each node indicating that the node already has been visited. Thus, a real set implementation is not needed at all. Even for the open set, we could technically completely avoid creating a set implementation. The idea would be to just always run through all nodes, identify those nodes with an open flag, and return the node with the lowest F cost. But this method always requires to run through the entire field, which is from the worst case execution time point of view not ideal. To overcome this problem, a separate sorted list has been introduced in which all open nodes are stored in ascending order with respect to the F cost. With this in mind, this structure has been created to store all relevant data. As you can see, both costs, G cost and F cost, plus the path indicator parent are stored. In addition, you see the two flags, open and closed, and a link to the open list where this element is located if the open flag is true. Here you see how the open list is working. At start, the source node is added to the open list. That means at index 0, the link to the corresponding grid element is stored. The pointer open list last entry index is always pointing to the first free location in the open list. Now all available neighbors are visited, starting for instance with the upper node. The costs are evaluated and the link is added to the open list. Since no other open node is present, the link is put at index number 1. Then the second neighbor is evaluated. Since this F cost number is lower as the previous node, this new link is sorted at index 1 and the existing link is moved to index 2. The last neighbor has the same F cost value as the first one. Thus, this link is just added to index 3. In addition, we have seen that the open list last entry index has moved now from index 1 to index 4. That also means that a new element only needs to be sorted between the two pointers open list last entry index and current index. At the beginning of the next iteration, the algorithm can just take the element from the next index from the open list, now 1, and continue the same steps from here. With this, no further searching or sorting is needed. This implementation reduces the amount of comparisons to a minimum.